Welcome back to our channel. So today we are going to discuss about the characteristic equation of an SR flip-flop. Okay, so this is very much important in understanding. So the first concept today we are going to cover is the characteristic equation of a SR flip-flop. Okay, so we will discuss about what is meant by a flip-flop and as well as a latch in the upcoming classes. Currently, let us try to discuss about the flip-flop. So in order to, this is actually an 1-bit memory storage device. So this is a 1-bit memory storage device, and this flip-flops to get enabled, it requires an enable signal. So when you give an enable input, then it is going to act like an gate and the flip-flop starts working. So therefore you are going to enable the input with the help of an clock pulse. So the first input we are going to give is clock pulse. When you give the clock pulse, so this is nothing but an edge triggered clock pulse. Now after the clock pulse we are going to have the decimal numbers. So how to draw the decimal number here, we'll try to justify. So the decimal numbers we are going to have as let's try to see how many possible decimal numbers are there. So what are the inputs I'm going to have is S is one input, R is another input, and Qn is one state, and another state is nothing but Qn plus 1, where Qn is called as present state, where Qn is called the present state, as well as Qn plus 1 is called as the next state. Now coming here, so how many inputs we are having is 3 inputs we are going to have. So therefore, how many possibilities you are going to get is 2 cube is equal to 8 possibilities. So therefore, you are going to write the decimal numbers from 0, 1, 2, 3, 4, 5, 6, 7. So 0 to 7, 8 decimal numbers you are going to get. So now let us try to fill the column one by one. So first one is 0. Okay, so therefore you are going to get how to write down. So this decimal is nothing but 2 to the power 0 is nothing but 1. This is 2, this is 4. So now how to write down this decimal of base 10 in terms of 3-bit binary is so we can write down it as 0 0 0. So this we can write down it as 0 0 1, and next we can write down the 2 as 0 1 0. We can write down the 3 as 0 1 1. So the next one we are going to write down it as, so now 2 plus 1 3 is there. Next one 4 0 0. Next one is 1 0 1. So next one is 6 I can write down it as 1 1 0. 7 I can write down it as 1 1 1. So this is how to write down the SR as well as Qn. So the Qn plus 1, when inputs are 0 0, so inputs are 0, then automatically you're going to get here the state. You're going to make a comment Qn plus 1 is equal to Qn. Therefore the output is same as it is. Whatever the value of Qn you're going to get, the same Qn you're going to get here. But in the case of when the input is 0 and 1, then the output you're going to get it as a reset. So reset means generally it is considered as 0. So here also you're going to get 0, and here also you're going to get 0. So this is what the inputs you're going to get for 0 1. The output is reset, and later on you're going to get the output as a 1 here for the conditions of 1 0 and 1 0. So this output is called set. So the value of set is 1 here. So after the output you're going to get here is into for example, this is Qn. So here you have to get two states. First one is Qn, and another one should be Qn bar. So when you're getting these two states, then these are called as two states. I mean, one is Qn and another one is complement. Therefore, two stable states are required, but it is not possible here. Therefore, like this you are going to get. Now I need to derive the expression for qn plus 1. So which is nothing but the characteristic equation, which is nothing but qn plus 1, and we are supposed to get the value as s plus r bar qn. So how to get this value? Now let us try to do here. So we are going to have s r qn. So now let's try to develop a k map. Okay, so when you're developing the k map, so here you are going to take s value, r value, and the another input we are going to take it on qn. So here I'm going to mark it as 0, and here I'm going to mark it as 1. So while marking it, how to consider is, so you have to take the values as the decimal values as 0, 1, 3, as well as 2. So like this, you can write down the 0 as 0, 0. We can write down the 0, 1 as in BCD as 0, 1, 3 as 1, 1, and 2 as so we can write down it as 1, 0. So this is how we are going to get here, and starting with q. So here we can write down this as q n. If it is qn, what is 0, which is called a qn bar. So how to write down s and r? So s bar r bar is nothing but 0, 0. So next one is s bar r. Next one is s r. Next one is s r bar. So if you write down s, it is 1. If you write down bar, which is nothing but it is 0. Then now let us try to see our table, how it to map. Okay, so coming to the mapping, so here you can see here. So here we are going to have the column. Let us draw the lines for the each individual column. So SR is 0, 0, and Qn is 0, then output is 0. So SR is 0, 0, and Qn is 1, the output is 1. And SR is 0, 1, the output is, Qn is 0, the output is reset. So this is nothing but 0, 1, and Qn is 1, therefore you are going to get 0. And next, 1, 1, 1, 1 with Qn as 0, indeterminate state. Okay, here, indeterminate state. And again, 1, 1 with 1, we are going to get a don't care condition. But with 1, 0 and Qn is 0, then you are going to get the value of 1 here. Okay, and 1, 0, 1, we are going to get the value of a set. So now we have to perform the k map and have to see how these are linked with each other. So here the 1 is there, this is one set of 1, and this is another set of 1 without don't care condition. So when you map these 4 values, here you can see here, so you have to take this 4 as 1. Why? Because here x is treated as a don't care condition. In this don't care condition, we should combine the all the 4. So when you combine all these 4, then you can see here what you are going to get. So one is q, one is complementary, you cannot take. And what is the common term here we are going to have is 1, 1. So therefore here you are going to get yes. And for this mapping of this k map or Karnaugh map, so 1, 1. Okay, so 1, 1, if you are getting mapped, you have to see that what are the variables it is getting mapped. So to this 1, what is the common term we are having? So this is plus, and this value you are going to have in this column, you are going to have q n, and vertically and horizontally 1 is there in this row, and this row here what is the common term? So 0, 0 is the 0, 0 is the common term, yes, and s bar. Okay, so both are different. What is the common term we are having is only r bar. So therefore here you can see here we have obtained s plus r bar qn is the characteristic equation of our SR flip-flop, which is a 1-bit memory storage devices which uses the gate as an input. Okay, so this is how to get the characteristic equation of an SR flip-flop. Hope you're able to understand. We'll meet with the another video how to get the SR flip-flop for D as well as SR flip-flop for JK flip-flop as well as for toggle flip-flop. Thank you for watching. We'll meet in another video.